A glass beaker has a volume of 50 ml at 30 degrees Celsius. Find its volume at 130 degrees Celsius given linear expansion coefficient for glass is 4 times 10 to the minus 6 per degree Celsius. Pause the video, see if you can try and solve this yourself first, and then we'll solve it together. Alright, let's do it. Let's write down what's given to us. We've been given the volume of the glass, so we know volume is 50 ml. And that is at the temperature 30 degrees Celsius. We need to find its volume at 130 degrees Celsius. What's important for us is not the temperature, but the change in temperature, right? That's what causes expansion. So change in temperature is final temperature, 130, minus 30, that's given to us. That is 100 degrees Celsius. So the temperature is increased by 100 degrees Celsius. That's given to us. What else is given? We've been given alpha L. Alpha L, linear expansion coefficient, is 4 times 10 to the minus 6 per degree Celsius inverse. And we need to find its volume, final volume. To do that, let's calculate the change in volume first. How do we figure out the change in volume? The change in volume is given as alpha V, that's the volume expansion coefficient, times V times delta T. And we have seen this expression in a previous video. So if you need a refresher, or maybe if you're not comfortable with this, it would be a great idea to watch that one first and then come back over here. So let's substitute and solve. Oh, but you can see one problem. We don't know what alpha V is. We need the volume expansion coefficient, but that's not given. Only alpha L is given to us. How do we figure this out? Well, in a previous video, we actually derived that alpha V is just 3 times alpha L. And if you're interested in seeing this derivation, you can again go back and watch that video. But anyways, now, since we know this, we can just substitute and calculate. Let's do that. So delta V is going to be alpha V, which is just 3 times alpha L. And alpha L is given to us. That is 4 times 10 to the minus 6 per degree Celsius inverse, times the original volume, that is 50 ml. So let's just slide that, 50 ml, times, what do we have? Times delta T, and delta T is 100 degrees Celsius. So times 100 degrees Celsius. All right, what do we get? Let's see. Degree Celsius and degree Celsius inverse cancels, right? And so what we end up with is 3 times 4, that's 12. 12 times 50, well, 12 times 5 is 60. You know what, let's just write that down. So we have 12 times 50 times 100. And what remains is ml. That makes sense, right? Delta V, change in volume. We should have ml. Okay, let's write this down. 12 times 5 is 60. So I get 60, but then there's 1 0 here. That's a 600. And there are 2 more zeros. And wait, I totally forgot this part. There is a 10 to the power minus 6. 10 to the power minus 6. So let's put that as well. 10 to the power minus 6. And so that gives us, let's count 6 decimals towards the left. 1, 2, 3, 4, 5, 6. So we would get 0.06 ml. That's how much the volume has changed. But we need to find the final volume, right? Well, we can do that. Since we know what the initial volume was, 50. So initial volume is 50. Final volume would be just the initial volume, 50 plus the change. So it was 50, it increased by 0.06. So the new volume would be just 50.06 ml. And notice the volume change is extremely tiny. And so we can justify that alpha v is equal to 3 times alpha L. You can only use this when the changes are very tiny, which is the case in this particular scenario.